Finally, we have it. We have an open weight model that everyone actually loves. It's called GLM 2.5, and it's also the first model that overtakes Claude on design since a very long time. And it sits near the top at every benchmark that actually matters. And that alone would be a story, but it's not the whole story. We have now frontier open weight models that companies can run for a very cheap cost. We have a pretty solid models that can run locally, even on our laptops. They're not great for coding yet, but they're getting there. And so I was asking myself, how did we even get here? Here are the 7 waves of innovation that brought open weight models to the frontier of intelligence. The first wave sounds a bit boring, but it has an incredible story behind it. Up until 24th of February 2023, pretty much everything was closed source. People just didn't have access to the technology until Facebook released Llama. They actually gatekept it initially and released it only for researchers. But of course, someone leaked the weights on the worst possible place imaginable, 4chan, after which a guy named Georgy Gerganov, who was, believe it or not, working on a Tensor library, writing some C code in his free time for absolutely no reason at all, got the weights and in one evening made the model run on CPUs. And overnight, an entire ecosystem around it appeared. So the first wave that we actually needed was someone to leak or release the weight. But there was a second challenge that people were facing when running AI, and it was that it was too expensive computationally. Like if you have a 100 billion parameters model, every parameter has to fire in order to predict the next token. And this is just extremely expensive. Luckily, the second wave of innovation helped here, and it's the mixture of experts. The concept actually dates to 1991, but the modern version was developed by Google in 2017 by the guy Noam Shazir. He has a story on his own. He left Google because they didn't let him develop his own stuff, and then they bought him back for 2.4 billion. Anyways, this is one of the people who invented the transformer, the LLM architecture, but he also invented the mixture of experts. Mixture of experts, probably many of you know, means not every weight or parameter in the model has to fire when you predict the next token. It is enough that only the subset of the important parameters for this specific prediction fires. For example, out of 100 billion, maybe only 20 billion parameters would fire when predicting the next token, and then there's a router in front of those experts. Now, in the open weight or open source community, the concept was made popular first by the European Mistral. They released the Mistral model, which was mixture of experts model. But DeepSeek from China, which is a spin-off from a quant hedge fund, like the stories in this space are absolutely incredible. It sounds super strange, but it makes a lot of sense that DeepSeek are a spin-off from a quant hedge fund because they had the compute and they had the researchers to improve the technology, and they improved on the original mixture of experts architecture by releasing even more fine-grained experts and a few shared experts that are always on. So DeepSeek V3 at the end had 670 billion parameters, something like that, and only 37 billion of them fired. This was extreme breakthrough and lowering the cost of running those models. But wave 3 was the wave that pretty much everyone is familiar with, and this was the aha moment. At the time, OpenAI has released O1, and the frontier wasn't about knowing things anymore, it was about reasoning. And reasoning was closed source. Until DeepSeek released R1, which was the first open weight reasoning model that also matched the performance of OpenAI frontier model, which was extremely impressive, and we all know what happened with Nvidia's stock price. It lost 600 billion overnight. But I think not enough is talked about the innovations that DeepSeek did there. Now, when you train a model, there are usually 3 steps. You have the base model that you have trained, this is step number 1. Then you have supervised fine-tuning, this is step number 2. And then in step number 3, you have reinforcement learning. What DeepSeek did was to run an experiment which was called DeepSeek 0, and they tried to remove this whole phase of supervised fine-tuning in order to find out what happens. And what happened is the aha moment. Reasoning emerged on its own. They didn't even have to apply supervised fine-tuning, and this is the famous phrase that you are all familiar with from DeepSeek. The model said, wait, that's an aha moment, I can flag here. In this 3-step process, there is another breakthrough that DeepSeek did, but this time in the reinforcement learning phase. Usually during reinforcement learning, the model would generate several options, and a smarter model or a human would pick the best option, and that's how you condition the model to become smarter. DeepSeek developed a more efficient way for reinforcement learning where there's a measurable outcome. The model can generate several options, then score them and picks the best one, and then this leads to recursive self-improvement. So removing or minimizing the step of supervised fine-tuning and then making reinforcement learning much more efficient, DeepSeek made extremely cost-efficient to train new models. But there was yet another challenge, and this challenge was about memory and about being able to have long context, which is super important for coding agents. When an LLM processes a sentence, it has to compute something that's called key values, and those key values are saved in a cache. And the longer the sentence or the longer the document that the model needs to process, the more this KV cache grows and the more memory this user occupies. So if you have a lot of users, you'll be eventually short on memory because your KV cache would just grow a lot. And again, DeepSeek was able to reduce this cache by something like 80 to 90% by storing a compressed version of those key values and then computing them on the fly during inference whenever you need them. The algorithm was called multi-head latent attention. This was a major breakthrough in making models much more memory efficient. And around that time, we started seeing context lengths grow. But there's another problem here. Whenever you generate the next token, you have to take those computed key values from the cache and then compute attention between every added token. So it's n times n operations, it's n to the power of 2, which is computationally very expensive. And from different labs, we had a lot of innovation here. We had sparse attention, which doesn't compute attention between every single token, but only between certain tokens. Then we have linear attention that makes the computation linear. We have llama that alternates local and global attention, and then we have hybrid approaches. And all those innovations led to longer context windows for coding agents, KV cache efficiency, and much more efficient computation of attention, which is at the heart of the LM architectures. Then waves 5, 6, and 7 are actually products of this year, maybe the last couple of months. Everything happened just so fast. Let's start with wave number 5. There's the difference between open weight model and a model that runs on my PC, because most of the open weight models were quite big actually before the release of Qwen 3.5, 3.6, and Gemma 4. Those were the first actually capable models. They were not great coders, but pretty much anything else they can do. They could be fine-tuned, they had a permissive license, they're actually useful for companies, they're actually super cheap, and I've tested both of them and I'm super happy with them. Then in wave number 6, again, just in the past couple of months, we had so many releases. We have releases from Kimi, from GLM, we had releases from Minimax, we have releases from DeepSeek, and all this knowledge is starting to travel between labs because everyone is publishing research papers, everyone is publishing their weights, and they can learn from each other and they can build on top of each other, which is when we got the GLM 5.2. There are so many videos on YouTube about it. The model is absolutely incredible. Everybody loves it. Finally, open weight model that is actually a great coder that companies are seriously considering to replace the frontier because the frontier is getting so expensive. And then the future lies in wave number 7, which is about routing, fusion, and orchestration. We have seen, I believe, by Open Router, a report where you can fuse two models. They can fuse Opus 4.8 and GPT 5.5, and then they could have a level of intelligence which is much higher than both combined, which makes a lot of sense because they have been trained on slightly different data. They have different weights, obviously. When you combine and fuse multiple models, you can get a model that is way more intelligent. Then there was another release from Tokyo, I believe, from the company Sakana AI that bets on orchestration. So you can train a model, just a router that sits in front of other models and then routes the request to the model that is more appropriate to solve the task, which again increases the intelligence. So you could have fusion of different models, you can have orchestration of different models, you can have routing between them and combine multiple approaches to get way higher intelligence. And I'm pretty sure the labs are aware of that because this is a great way to also distill knowledge and train the next model. So that's how we got here. Those were the 7 waves of innovation. In about 3 years, we went from leaked weights on 4chain to a model that actually displays frontier level capabilities, that is open weight, that is extremely low cost, that beats cloud design and is at the top of every single benchmark. And the best part is that intelligence is being democratized, and all of this is not hype. This is just a trend that would keep going. If you want deep technical dive on any of those innovations, please let me know in the comments. I'm happy to do them. I'm just afraid that it would get a bit dry and a bit boring, but yeah, let me know please. Thanks a lot for watching. See you next time. Vielen Dank für das Zuschauen. Bis zum nächsten Mal. Благодарю за следващия път.